right?
Wait, sorry,
Takes
what?
an hour. She said about.
To do the test?
Mm-hmm.
Yeah.
I feel like since we have one and she has one, let's look over it and try to do the ones we know, and so it doesn't take all the time.
Okay, we're broadcasting.
How'd you do on the quiz?
What quiz? Oh, I got 11.
Me too. Which one?
I got a 10.
Boo. No, I studied 20, 30 minutes. No, I studied in the morning a little bit.
You acted like you were studying last night. Did you?
Yeah, you texted last night and asked about it.
Oh, I was going to. I wanted to figure out, but she texted us last night, but I never got around to it, so I just did in the morning. Okay, this is going. Who had 1 through 3?
Me.
You, Mo.
Okay.
You had 4 through 6.
So I guess I'll just do number 2. It had a lot of steps, so you had to get the first steps to figure out the last. So for letter A, you had to put 7 meters per second equals the angular acceleration times 0.28, and then you just do the math for that, and it equals -25. What is that? Radians per second?
Radians.
Radians per second, yeah. And then for B, you have to do 95 squared plus 2 times 25 over the angle, and then you divide it. Do the math, and equals 181 radians. And then for C, you have to take 95 plus -25 times t, which equals 3.8 seconds for the car to completely stop. And then for D, the distance the car travels, you do 0.28 meters times 181 radians, and then it equals 50.7 meters. And then the car's initial velocity, you times 95 times 0.28 and equals 26.6 meters per second. And then letter F, yes, it is reasonable. That's the answer. Your turn.
Let's see. Where is my work? It is tucked away. I'm going to screen share because I do not. Okay. So for number 4 is the motorcycle question. If, oh dear, there's my question.
I might have it.
Yeah. Okay, so it's a 12 kg motorcycle. Assuming it's approximately an angular ring with an inner radius of 0.280 meters, outer radius of 0.330 meters. Motorcycle is on its center stand, so the wheel can spin freely. So, okay. So for question A, if the drive chain exerts a force of 2,200 newtons at a radius of 5 centimeters, what is the angular acceleration of the wheel? So I took the, my goodness. So I took 2,200 newtons and multiplied it by 0.05, which is 5 centimeters converted to meters, which equals 110 newtons a meter. Then the equation for inertia is I equals mass times the inner radius squared plus the outer radius squared, which is given, and it's 0.28 and 0.33, and then you divide it by 2. So I ended up getting 1.124 kgs a meter. So I took 110 newtons a meter and divided it by 1.124, and it gives you an angular acceleration of 97.9 radians. 97.98 radians a second. And then for part B, the tangential acceleration of a point on the outer edge of the tire, all I did was I took the outside radius, multiplied it by the angular acceleration. So 97.9 times 0.33 equals 32.3 meters a second. And then for C, if starting from rest, how long does it take to reach an angular velocity of 80 radians? As easy. So if it's going at 97.9 radians per second, you just do 80 divided by 97.9. That equals 0.82 seconds to reach 80 radians.
All right, and I had 7 through 9. I'll just do 8. So 8 was like hers. Yeah, it was different steps. You had to get the first one. So it says, calculate the angular motion of an ice skater spinning at 6 revs a second, given the moment of inertia is 0.4 kilograms meters squared. So you times 6 times 2 pi equals 37.7 radians per second. And so then you times that by the 0.4 kilograms, and you get 15.8 kilograms. And so the next one, it was reducing the rate. So you do 2 times pi times 125 equals 7.8. And then C is he keeps his arms in and allows frictions to slow down the ice at 3 revs. What is the average torque was exerted to take 15 seconds? So you take 2 pi times 3 equals 18.8. So then you do 18.8 minus 37.7 radians, which we found in the first question. And then you divide that by 15 seconds. That equals negative 1.26. Then you times 0.4 kilograms squared times negative 1.26 squared, and you get negative 0.504 newtons. And that was 8. 6, 7, 8.
So, good meeting. We'll see you next week.